Today we will be looking at creating equations from ratio tables, and our goal is going to be to write two equations to show the relationship between the variables in each of the ratio tables we look at. There are two key ideas we're going to focus on as we try to create equations today. The first one is that we're going to focus on the relationship between one column and the next. And the second is that we're going to write an equation for each variable in terms of the other. So that's where we're going to get our two equations from. So using that first bullet, what I want to focus on is I want to look at how the numbers in column C are related to the ones that I find in column D. So the first thing I want to take a look at is, what are my possibilities? When I go from 24 down to 4, there's a couple of things that could happen. I could have subtracted 20, because if I take 24 minus 20, I'm going to get 4. Or I could have divided by 6. Because if I take 24 divided by 6, I'm going to get 4. Multiplication, I know if I start with C and I multiply by something, I'm going to get bigger, unless I'm multiplying by a fraction or a decimal. And for right now, we're going to focus just on whole number relationships between our numbers. So the same thing then is true with addition. I can't add anything to 24 other than a negative number. And as we haven't gotten into negative numbers yet, we won't be using all of those. So those are my two possible relationships. Now, the way I decide which one is going to be my answer is I have to look at the other rows as well, because all the rows should have the same relationship. So if I go from 36 to 6 and I take away 20, that doesn't work. 36 minus 20 would have given me 16, not 6. So that takes off minus 20. Even if minus 20 works for the other rows, which in fact when I look a little closer I see it doesn't. 72 minus 20 would have been 52. Same thing as we go through. That leaves division by 6 as the relationship. And if I notice the rest of the table, I see that that holds true. 36 divided by 6 is going to give me 6. If I take 72 and divide by 6, 6 goes into 7 one time. It's going to give me a 1 and a 2, so it's going to go in twice, which leaves me with 12. And the same thing happens for 132 divided by 6. I'm going to get 22. And 186 divided by 6. So now I have to write a formal equation. Now, an equation has an equal sign in it. We see the beginning of the word equal at the beginning of the word equation. So what I'm doing is I'm taking my variable C and dividing it by 6, and that's going to tell me my answer for D. What should be true of your equation? If you take any of the rows in this chart and you substitute them in for the appropriate letters, the resulting equation should prove true. So if I take 72, because 72 is my C value, and I divide it by 6, I should get my D value, which is 12. And again, if I take 72 and I divide by 6, I get 1. I subtract, go through. 6 is going to go in twice, which is going to be 12 exactly. And again, I can check that for each and every value. So once I have that pattern, I'm really at a good spot to help me determine my equation. What I have to remember, though, is here I'm writing two equations. So now I want to go backwards. So that means instead of going from C to D, I'm going to go backwards. Well, how did I get from C to D? Well, this is just as simple as knowing my opposite operations. If I divided by 6 to go from C to D, I'm going to be multiplying by 6 to go the opposite way. And again, I notice that that proves true. If I do 4 times 6, I'm going to get 24. If I do 6 times 6, I'm going to get 36. If I do 12 times 6, I'm going to get 72. And that pattern continues as I go on. So what I have to remember when I'm writing my second equation is this time I'm taking my D value and I'm multiplying by 6. Remember when I use algebra, I no longer use that X. So for multiplication purposes here with a number, that was fine to show. But in my equation, I'm either going to write 6D like this with the number right next to the letter equals C, or I'm going to write it as D, and I'm going to use the dot for multiplication, so D times 6 equals C. I'm going to focus on the top one because typically that's what we're going to see as we move forward in algebra. They're going to use the example where the number is right next to the variable. So in my black boxes, I have my two equations that show the variable. Notice in one of the equations, we have the letter D by itself, and the other we have the letter C by itself. That's what it means to talk about one variable in terms of the other. Here I have that D equals C divided by 6. So the variable D is written in terms of what I do to the variable C. Here I have the letter C equals 6 times D. So the variable C is written in terms of what I do to that variable D. As I move on to my next example, I'm going to do the same thing. I'm going to start by going from X to Y. There are two possibilities. I could have either added 6, so done 6 plus 6 is 12, or I could have multiplied by 2. 6 times 2 equals 12. Again, if I subtract, I'm not going to be able to get a bigger number unless I'm dealing with negatives. And same thing with division. Unless I'm dealing with fractions or decimals, which I don't want to get into, that's why I only have those two options. So now I have to see which one proves true for the next one. Well, 7 plus 6 equals 13. 8 plus 6 equals 14. 9 plus 6 equals 15. And 10 plus 6 equals 16. So looking like the plus 6 is going to be the option. And when I look at the next one, if I did 7 times 2, that should have equaled 14, not 13. So that tells me that plus 6 is my relationship. So for my equation, I'm going to take my x, which is my first column. I'm going to add 6 to whatever that value is. And then I'm going to get y as my answer. That's my first equation. Now I'm going to go backwards. I'm going to say, well, what did I do to get from y to x? Again, I'm going to use that idea of opposite operations. If I added 6 to go one way, I'm going to be subtracting 6 to go the other way. And I can check to make sure that works. 12 minus 6 is 6. 13 minus 6 is 7. 14 minus 6 is 8. 15 minus 6 is 9. And 16 minus 6 is 10. So it looks like that relationship holds the whole way through. So this time I was starting with the y. I took my y value, my value from this column. I took away 6 from it. And that told me the answer that I found in the x column. So here I find my two equations are y equals x plus 6. So the variable y is given in terms of what I do to 6. Then x equals y minus 6. X is given in terms of what I do to y to get that answer. If you're feeling confident with how this works, I suggest and encourage you to pause the video and give the next one a try before I go over it with you, or you can follow along and hear me go through another example. So I'm going to start with column A and see what did I have to do to get from to column B. So I start with 10 in A. I could have subtracted 5 from 10 to get 5, or I could have divided 10 by 2. That also gives me 5. So those are my two options this time because I got smaller. I'm going to need to take a look at then which of those two proves true throughout the rest of the table. So if I do 15 minus 5, I do get 10. 20 minus 5 is 15. 25 minus 5 is 20. 30 minus 5 is 25. So that's probably indicating that subtracting 5 is going to be my answer. But let's check dividing by 2 just to make sure. If I divide 15 by 2, 15 is not an even number. I know I'm not going to get a whole number answer. 15 is going to go, or 2 is going to go in 7 times and then a half. So I'm going to have 7 and a half as my answer, and that table indicates 10. So I'm not going to be able to use division by 2. So when I write my formal equation, I'm going to take my letter A for that first column. I'm going to take away 5 from it, and then that's going to give me my answer from column B. When I go backwards, again, I use that opposite operation. Well, if I subtracted 5 to go one way, I'm going to add 5 to go the other. And again, if I check that out, 5 plus 5 is 10, 10 plus 5 is 15, 15 plus 5 is 20, 20 plus 5 is 25, and 25 plus 5 is 30. So my formal equation, I'm going to take the letter B, because that's where I started. I added 5 to that value, and it told me what my A value was. So these are going to be my two equations. This is the last example we're going to do together, but if you're feeling confident, pause the video, give it a try before I go over the answer with you, and then check to make sure you got it right. If I'm looking at column M, seeing what I do to get to column N, two things I could have done. I could have added 20, because 20 plus 5 is 25, or I could have multiplied by 5, because 5 times 5 is 25. Now, if I try that adding 20 pattern, 20 plus 9 should have been 29, but it showed 45 here. 20 plus 16 should have been 36, but it shows me 80. So there's no way I could have added 20 as my pattern. Let's check multiplying by 5. If I do 9 times 5, I get 45. If I do 5 times 16, 5 times 10 would be 50. 6 times 5 would be 30. Add that together, get 80, so good. 5 times 24, I would do 5 times 20, which is 100, plus 5 times 4, which is 120, good. And 5 times 20 is 100, plus 5 times 7 is 35, 135. So it looks like times 5 is my pattern. So I'm going to take my m value and multiply by 5. So I'm going to show that by putting the 5 right next to the m. And that's going to equal or tell me my value for letter n. When I go back the other way again, I'm going to think of opposite operations. If I multiplied by 5 to go one way, I'm going to divide by 5 to get the other. 25 divided by 5 is 5, 45 divided by 5 is 9, and so on. So I'm going to take my n value, I'm going to divide it by 5, and that's going to tell me my m value. So my two equations are as follows. At this point, take a look at the back of your sheet. It gives you a couple more examples of ratio tables. For each of those, I'd like you to give me two equations that can be used to show the relationships there. And then make sure you indicate how comfortable you felt with each of those problems. Remember, you could have different numbers for each of those if you feel that way. Then give me your questions, comments, or concerns if you have any, or let me know that you felt it was easy if you don't really have any worries with that, and we'll go over and talk a little bit more in depth about these tomorrow.